My students attended my 5th grade resource room for extra help with their learning disabilities. This digital story will demonstrate my students' misconceptions while dividing fractions. Within the article Cognitive Apprenticeship, Making Thinking Visible by Collins, Brown, and Hullum, they discuss how conceptual and problem-solving knowledge acquired in school remains largely inert for many students. In some cases, knowledge remains bound to surface features of problems as they appear in textbooks and class presentations. For example, Schoenfeld has found that in solving mathematic problems, students rely on their knowledge of standard textbook patterns of problem presentation rather than on their knowledge of problem-solving strategies or intrinsic properties of the problems themselves. When they encounter problems that fall outside these patterns, students are often at a loss for what to do. I was able to find a few YouTube clips that provided a different strategy.
Welcome to this video on dividing fractions. Hopefully you remember how to multiply fractions because basically that's what you're going to be doing when you're dividing fractions, with one little difference here, which is highlighted in purple here, our golden rule of dividing fractions. Dividing by a fraction is the same as multiplying by its reciprocal. Now there's kind of a fancy word there, reciprocal. Reciprocal is just basically when you take a fraction and you flip it over. The numerator becomes the denominator becomes the numerator. Let's look at a quick example of what a reciprocal would be. If we have the fraction 3/4, the reciprocal would be 4/3. Pretty easy. You just flip it over. If we had the fraction 1/2, the reciprocal would be 2/1, or 2. If we had the number 6 and we wanted to find the reciprocal, we'd have to write it as a fraction, like 6/1, and then flip it, 1/6. If we had a mixed number, like 3 1/3, in order to flip this or find the reciprocal of this, we'd first have to turn it to an improper fraction. 3 times 3 is 9, plus 1 is 10, so we'd have 10/3. Then we could flip it or find the reciprocal, which would be 3/10. Alright, so we're going to be using this idea of the reciprocal of a fraction here when we're dividing. Let's look at an example. Let's get rid of this. Okay, let's do 3/4 divided by 1/8. Alright, so dividing by a fraction is the same as multiplying by its reciprocal. Dividing by a fraction. So the fraction we're dividing by is 1/8. So dividing by 1/8 is the same as multiplying by its reciprocal, or the reciprocal of 1/8. It's only the 1/8 we're going to do the reciprocal of, not the 3/4. The 3/4 is going to stay the same. 3/4. Then it says we're going to change this to a multiply, and we're going to do the reciprocal of 1/8, which is 8/1. That's it. That's the key right there. Change the divide to a times, and take the reciprocal of the fraction that you're dividing by, which is the one right after the divide sign. Now we just have a multiplication problem, which we already know how to do. So let's see, is there anything I can cancel? Remember, you can only cancel when you're multiplying. If I could not cancel if there's a divide, even there's nothing here to cancel, but even if I could, even if there was something that could cancel, I can't do it because there's this divide sign here. I can only do it when there's a multiplication. Okay, so 4, 8, looks like I can cancel there. Let's do that. So 4 goes into 4 once. 4 goes into 8 twice. Now we multiply straight across. 3 times 2 is 6. 1 times 1 is 1. 6 divided by 1 is 6. So 3/4 divided by 1/8 is 6. Now that's a little strange to think about. Like what's happening here? 3/4 divided by 1/8. Why does that come out to be 6? Well, let's see if I can give you a little bit of help with this, a little picture. Let's see, of what's happening. So we have 3/4. Here's 3/4. So say I've got 3/4 of a pizza, alright? and I'm going to divide it by an eighth. So in other words, I'm asking myself how many eighths will go into 3/4. That's what division means. If I had a simpler problem like 8 divided by 2, I'm just making this up totally just because it's a division problem that you understand. What this means is how many 2's will go into 8, and the answer is 4. 4 2's will go into 8. Okay, let's just kind of remember that's what division means. So up here, when I'm saying 3/4 divided by an eighth, I'm asking how many eighths will go into 3/4. So let's go over here and let's think of this as, you know, it was a whole pizza here at one time, but the part we have left is 3/4. And I want to split it into eighths. How big would an eighth be? Well, if this is a quarter of the pizza right here, then if I wanted to split it into an eighth, I'd have to cut this in half right here. So this piece, that would be an eighth. And then this piece right here, that would be another eighth. So there's two pieces there that are an eighth. There's 3, 4, I think you can see what's going to happen here, 5, and 6. So each of these red pieces here, those are an eighth of the pizza. And how many eighths will fit into 3/4? 6 of them. 1, 2, 3, 4, 5, 6. So that's what's happening. It's always good to get a picture in your mind of what's going on. What does this problem mean? And is 6 a reasonable answer? And in this case, it is. We can see that by the picture. All right, let's try another one.
We're dividing fractions, dividing fractions. We're dividing fractions. I can do it, you can do it, he can do it, she can do it. Dividing fractions, dividing fractions. We're dividing fractions. I can do it, you can do it, he can do it, she can do it. Now you take your fractions and line them up side by side. Then you flip your second fraction, the one you want to divide by. Then the numerator times the numerator you multiply. Then the denominator times the denominator you multiply. Take your fractions and line them up side by side. Then you flip your second fraction, put your bottom number on the top, top number on the bottom. Then the numerator times the numerator you multiply. Then the denominator times the denominator you multiply. Then reduce to simplest form. 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 We're dividing fractions, dividing fractions. We're dividing fractions. I can do it, you can do it, he can do it, she can do it. Dividing fractions, dividing fractions. We're dividing fractions. I can do it, you can do it, he can do it, she can do it.
One video showed from start to finish on how to divide fractions, and it also provided an analogy of dividing up a pizza. Having my students draw pictures was a great way to check their work. The other video was a catchy hip-hop song on how to divide fractions. For my students with learning disabilities, projecting these two YouTube clips provided them with new strategies that were easier to remember. Siegler's overlapping waves theory is a perfect way to describe my students' learning. They will typically need a variety of strategies and a way of thinking rather than just one to solve a problem. My students were able to overcome their misconceptions by the use of these two supplemental multimedia clips and by modeling several examples. By showing the students a different method/strategy from which the general ed teacher used from everyday math, they were then able to grasp the steps needed to solve their problems.